In section 2.5, we're going to be looking at properties of our trig functions. We're going to start with sine of theta. And keep in mind that when we're talking about this, let's think about we have a right triangle and here's our angle, and then we have our opposite and our hypotenuse, and this is what's determining sine. Now really, as we work our way around a unit circle, we could plug in any value we want for theta. We could have any angle. That is our domain. We could have negative numbers, we can have positive numbers, we can have any angle and work our way around. So our domain for sine, or for theta, is going to be all real numbers. Now that being said, because of the way this works out, what we actually get when we're talking about opposite over hypotenuse is that our range is limited. We could have negative angles, which is going to give us some negative values. We could have positive angles, but because we're looking at that range as opposite over hypotenuse as a fraction, and the hypotenuse is always going to be the longest side in the triangle, our range goes from -1 to 1. Because it's always going to be in between those values. The smallest we could get is when the opposite and the hypotenuse are equal to one another. That's going to happen along an axis, and that could be a negative or a positive 1, but we would not go any greater than that. That's why when you take something like the sine of theta is equal to, say, 1.43, and you solve that and take the inverse of both sides, you're going to get an error, because there is not an angle that will happen in a triangle where your opposite side is going to be bigger than your hypotenuse. Now, we also could talk about the period of this function. All right, we know that we go around in a circle 2 pi or 360 degrees, and then it starts to repeat itself, because it doesn't make a difference how many laps we make around. When we're talking about 30 degrees or 390 degrees, we're still going to get the same value. It starts to repeat itself. So when we're talking about the sine of theta, that's equal to theta plus 2 pi, because as we make those laps around, and we could multiply that by any value k, and it's still going to come back to just being our theta value. So that's our period for sine. Now as we talk about cosine, again, think about your triangle. We can have any angle for theta. Now we're talking about our adjacent and our hypotenuse. All right, so again, our domain, we could have any angle. So the domain is all real numbers again. And again, our range, because we're talking about a fraction here, and the only time we could have here is the adjacent equal to the hypotenuse, so we could end up with -1 to 1 for those values, but we will not have the adjacent larger than the hypotenuse. So again, same example, if you're talking about the cosine of theta equal to 1.43, and you take the inverse cosine of both sides, again, you're going to get an error, because there is no place where your adjacent side is going to be bigger than your hypotenuse. And then again, our period is 2 pi or 360 degrees. Because again, then it starts to repeat itself. So again, we could say that the cosine of theta is going to be equal to the cosine of, and that angle can change. We can add 2 pi to it, or anything times 2 pi, and it's still going to come back to that theta value. Tangent. Now remember, for tangent, that is sine divided by cosine. So we could have, for our domain, all real numbers except our cosine of theta value cannot equal 0. All right, and that happens on odd multiples of pi over 2. Right? So that would be, for example, pi over 2, 3 pi over 2, 5 pi over 2. If we're making multiple laps, or we could talk about negative values as far as that goes. So we could say all reals except except for where the cosine of theta is equal to 0. Then we can't have that because that's on the bottom of our fraction. And our range, well, we're taking sine divided by cosine. We could end up with any value here and any value here. So really we end up with all real numbers, R-E-A-L, there we go, all reals for our range for tangent. Now, tangent, as far as the period goes, it starts to repeat itself at pi, or at 180 degrees. And that, so its period is shorter than sine and cosine. Now with cosecant, remember that's equal to 1 over sine. The period for this is going to be the same as we have with sine, 2 pi or 360 degrees. The domain, we can have all reals except for, this is what we have to watch out for, is when sine of theta is equal to 0. So we could have all reals except when sine of theta is equal to 0. We can't have that. And that happens on any multiple of pi. All right, so pi, 2 pi, 3 pi, any multiple of pi gives us a sine value of 0, so we can't have those values as part of that domain. Now our range, remember we said that our sine values, that we're going to get a fraction. It's going to be 1 or less. So what we're going to end up with is we're going to have a range which we could have negative values and we could have positive values, and they're going to go from negative infinity up to 1, negative 1. And then we're also going to have values, so we have a union going from 1 to infinity. But because this value is going to be a fraction, we won't have any values in between negative 1 and 1. Same idea then when we look at the secant. All right, again, our period is going to be 2 pi or 360 degrees because we're talking about the reciprocal of cosine. And again, our domain, we have to watch out for when cosine of theta is equal to 0. We can't have that here. So we have all reals except for when cosine of theta is equal to 0. And again, that happens on odd multiples of pi over 2. And then again our range, same idea. We know that our cosine values are going to be fractions. So again, same idea as what we had just above with cosecant. We can go from negative infinity to negative 1, and then its union with 1 to infinity. And when we look at the graph of this, that's going to make a lot more sense of what's going on here. Now cotangent is going to have the same period as tangent. That's going to be pi or 180 degrees, and it starts repeating. And again, your values, cosine over sine. So as far as that domain goes, again, we have to watch out for any multiple of pi because the sine of theta cannot equal 0 since it's on the bottom of the fraction. That happens at any multiple of pi. So all reals except for those values where we have pi. Now our range is going to be all real numbers. All right. Now let's also remember our even and odd properties. If we plug in the opposite of x and we get back our original f of x, then that would be an even function. And remember that would also have symmetry to the y-axis. Now if we have an odd function, now when we plug in the opposite of x, we get the opposite of the original. And this time we have symmetry to the origin. So if we look at the sine of, and let's say we plug in the opposite of theta, that's going to give us the opposite of sine of theta. Sine is an odd function. So that means that also cosecant is an odd function. If we're looking at cosine of the opposite of theta, that gives us back our original. Cosine is even, which then means that secant is also an even function. Plug in the opposite of theta, we get back the original. Tangent is also an odd function. Which then again means that, our cotangent, that's cotangent, is also odd. The opposite of cotangent of theta.